Hello everyone, today we're looking at SAT Math, geometry and trigonometry. More specifically, we're looking at right triangles and trigonometry, and as always, we have a set of 5 difficult level questions. So, before we get started in our subject, I need to talk to you about, what is the basics of trigonometry. So, trigonometry basically states, at its most basic level, if you have a right angle triangle, forgive this terrible triangle drawing, but pretend this is a perfect triangle here and it's a right angle triangle, okay? So this is your right angle, right? And you're taking this angle, okay? Say this is your adjacent angle, okay? Because adjacent as in it's the one closest to this. And then say this one's opposite to your angle, okay? And then this one, your longest one right here, is your hypotenuse, okay? Say you have all of that. And then, if you take this angle and say this angle is theta, theta is just like a circle with a line in the middle of it, then sine of theta, wait, let me actually draw that part. It might be easier that way. So not draw, but write that part. Then what you'd have is, if you have the sine of that angle, right? So sine of theta would be equal to the opposite over the hypotenuse, okay? So this side right here over your hypotenuse. Cosine of theta would be equal to adjacent over hypotenuse, okay? And then lastly, your tangent or tan of theta is equal to sine of theta over cosine of theta, okay? And simplifying this out, remember your sine of theta is equal to opposite over hypotenuse, and then you're going to be dividing this, let's see, how do I get, okay, yeah, I'll just put it like this, parentheses, divided by your cosine, right? So your cosine is, I guess you could say it's your adjacent over hypotenuse. And when you're dividing this, it's going to leave with opposite over hypotenuse times hypotenuse over adjacent, right? Your hypotenuses cancel out, so you're left with opposite over adjacent, okay? So your tangent of theta is equal to opposite over adjacent, okay? One easy way you can remember this is so, ka, toa, okay? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Okay, and you do have some more advanced trigonometric terms, but usually not tested on them in your SAT. I'll just tell them to you just in case. Okay, so sine, right? If you take, okay, I'll go like this. So you have something called cosecant, which is equal to 1 over sine. Okay, you have something called secant, which is equal to 1 over 1 over cosine. Okay, and cosine is just cos. I'll just put cos. And lastly, you have cotangent, which is cotan, and then this is equal to 1 over tangent. Okay, so simplifying this a bit further, you get cosine is equal to 1 over opposite over hypotenuse. So that will be equal to hypotenuse over, hypotenuse over opposite, right? Your secant is equal to 1 over cosine, and cosine is equal to adjacent over hypotenuse. So secant is equal to hypotenuse over adjacent. And lastly, tangent is, opposite over opposite over adjacent. So 1 over that would be adjacent over opposite. Okay, so basically you're taking the reciprocal. And that's honestly all that you would need to know for your basics of trigonometry. You don't need to learn how to apply it in your unit circle or anything like that. So that's just your basics that I'm teaching you right now. Okay, now moving on to your problem, it says in triangle XYZ. Okay, so let's draw a triangle. Z is a right angle triangle. Okay, so it's a right angle triangle. So this is the right angle, and it's z. Okay. So if this is xyz, then this could be angle x, and then this could be angle y. I know this is not the best drawing in the world, but hey, it's as best as it can do. And it says the length of YZ is 24 units. Okay, so this is YZ, it's 24 units. If tan of x is 12 over 35, what is the perimeter in units of triangle XYZ? So tan of x. So the angle, which is theta, is angle x. So remember, you can use your trigonometric functions for all of your angles in a right angle triangle other than your 90 degree. So you can take the tan of x. You can also technically take the tan of y. However, you cannot take the tan of z. Okay, so you can. In this case, we're only focusing on x. Okay, remember, tangent is opposite over adjacent, right? Your opposite is 24. Your adjacent is we don't know. Okay? So we know that opposite over adjacent is 24 over, say, x. Okay? And what do we know? We know that this is equal to 12 over 35. Right? So knowing all this, we can just use you can just figure this out easily because this fraction has to be equal to this, so they're equivalent fractions. And 12 is just 24 is just 12 times 2. So that means that 35 times 2 is 70. So x is equal to 70. Right? Now the rest of this is easy. We just use the Pythagorean theorem. And for this you can just use a calculator. So you have a squared plus b squared is equal to c squared, right? Which is 24 squared plus 70 squared should be equal to c squared. And you can use that to figure out what c is. And remember, in your test, you have a calculator, and that makes things a lot easier, right? So 24 squared plus 70 squared is equal to c squared. Take the square root of this, and you get this is equal to 74. C is equal to 74. And now what some people would do is just say, oh, that's your answer, and just move on. But remember, you cannot do that. We're asked to find the perimeter, right? So you have to add up 24, 70, and 74. So you can just add them up. That's not really that difficult. And doing that, we get 168 as our answer, which is B. Okay, let's move on to our second problem. Okay, our second problem says, triangle ABC above is a right angle triangle, and sine B is equal to 5 over 13. What is the length of side BC? Okay, remember, sine is equal to, sine is equal to opposite over hypotenuse. Remember, so sine is equal to opposite over hypotenuse. So you're using sine B. So your theta in this case is B. So opposite would be this angle. So x over 13, x over 26. Remember, your hypotenuse is 26. And by the way, your hypotenuse is a side that is opposite to your right angle triangle, in case you didn't know. This would be equal to 5 over 13, right? And then these are similar triangles, so you can figure out that x is equal to 10. Now, there are some of you that know what your 5, 10, 13 triangle is. So, your 5, 10, 13 triangle, 5, 10, 13? 5, 12, 13. Yeah, your 5, 12, 13 triangle is, your 5, 12, 13 is just like a set of triplets that make up a right angle triangle. And some of you would also know that by multiplying, by a certain amount, you can still get well, if you know this, you would know this, but anyways, if you can do this, you can figure out that this is your 24. But for those of you that don't know this, just use your Pythagorean theorem. A squared plus b squared equals to c squared. we have 10 squared plus b squared would be equal to 26 squared, and then you can use that to figure out what is b. But for you guys that know what a 5, 12, 13 triangle is, this makes it a lot easier to solve. Moving on to our next question, it says rectangle ABC is shown. What is the value of tan A? Okay, so how can we figure this one out? Okay, so if we look here, there is one key clue that we can use. But I'll have to go into a bit more background information before I can tell you how to solve this problem. So this problem involves the use of special right triangles. So special right triangles are ones that you can figure out what your angles, so what your sides are without the need for trigonometry. So there are actually two special types. I'll show you both of them. So one is your 30, 60, 90 triangle. Okay, so say this is your 30. Okay. Say this is your 60. And of course, your other one is your 90. Okay. And then say the side opposite to the 30 is x. Okay. This would mean that the hypotenuse is 2x. Okay. And this would also mean that your side opposite to the 60 degree is x square root 3. Okay, and if you think about it, it kind of makes sense, right? Because if you know a bit of triangles, you know that the side opposite to your angles has like a corresponding let me put it this way. Your angle, right? The side opposite to your smallest angle is also the smallest, right? And then your side opposite to your largest angle is also your largest. And that's the reason why your hypotenuse is always the largest. Because your angle here is 90 degrees, which is the greatest out of all three of your angles. Thus, it has to be larger, right? Your hypotenuse is always the largest. So that means that your 30 degrees has to be your smallest, and then your 60 degrees has to be the second smallest, and your 90 degree angle has to be your largest in terms of your opposite sides. So in this way, we're multiplying square root 3 to your side opposite to 60 degrees, and we're multiplying times 2 for your hypotenuse. Your other special right triangle is your 45, 45, 90 triangle. Actually, let me clear this drawing. And as I was saying earlier, if you have your angles correspond with the sides of triangles. So that means that if you have, say, a 90 degree angle, and you have 45 degrees, okay, I'll just put like this, 45 degrees, that means that the side opposite to them has to be the same thing, right? So if this is x, this also has to be x because they're the same angle. And this is how it works with equilateral triangles, right? Now, what we can do is just simply use the Pythagorean theorem in order to figure out what your side opposite to your 90 degrees or your hypotenuse would be. And in this case, it would be x squared root 2. So your side lengths of your 45, 45, 90 degree triangle are x, x, and x squared root 2. And that's your basic run on your special right triangles. And that's how we're going to be solving these problems right here. So if we look here, this is a 30, we have 30 and 90 degrees. So that means that this angle has to be 60 degrees because all angles of the triangle had to add up to 180 degrees, right? So remember, your side opposite to your 30 degrees has to be the smallest. It has to be x. And then this side right here, CB, is x squared root 3. And then lastly, this side is 2x, right? And if 2x is equal to 54, that means that x is equal to 27. And x squared root 3 is 27 square root 3, right? And now we need to figure out what is tan A. We know that this is the angle, this is our theta, right? And we're trying to figure out what is the tan of this. So remember, SOHCAHTOA, TOA is tan is opposite over adjacent. So your opposite is 27 square root 3, right? 27 square root 3 divided by your adjacent, which is your 27, right? So 27 square root 3 divided by 27 is equal to square root 3. And that would be our answer. So let's see if that is an option choice. There. And indeed it is. So it would be option choice C. Okay, moving on to our next problem. It says, a graphical designer was creating a logo for a company. The logo shown in the figure above. The logo is in the shape of a trapezoid and consists of 3 congruent equilateral triangles. If the perimeter of the logo is 20 centimeters, what is the combined area of the shaded regions in square centimeters of the logo? Okay, so we know with equilateral triangles, right, all of the angles are 60 degrees, right? This is 60, this is 60, and this is 60. We also know that all of them have the same side lengths. Remember, if all of your angles are the same, that means that your side lengths also have to be the same, right? So now there are actually, I guess, 2 ways to solve this. One is using your special right triangle, and the other is by knowing your area of an equilateral triangle formula. I'll first show you using 30, 60, 90 triangle. So first we know that the perimeter is 20 centimeters. And we know that each of these sides are the same. So we have 1, 2, 3, 4, 5 different, I guess, triangle sides, right? And I'm saying triangle sides because that's what's same. Remember, your trapezoid has a different base. It's 2 of the triangle sides. But anyways, we have 5 of your triangle sides by x, right? And this should be equal to 20. So that means that x is equal to 4. So that means that your equilateral triangle has side lengths of 4. Oh, let me actually make that bigger. Okay. This is not the best equilateral triangle, but hey, it'll have to work. Now, here's how you solve this using your special right triangles. Well, you know that this is 60 degrees, right? Now, we also know that this angle is 60 degrees. But what would happen if you drop a height right here? Right? What would happen if you drop an altitude? Then that means that this angle becomes 30 degrees. And this angle right here would thus become 90 degrees. And we know how to solve our special right triangle. The side opposite to 30 degrees is your smallest, and thus would become 2. You actually didn't need to figure that out anyways, because if you're dropping this, it's being divided into 2 pieces, and this is already 4. So 4 divided by 2 is 2. And that means that this is also 2. And that's how kind of like you can figure out how your 30, 60, 90 triangles existed in the first place. This is how they were actually found out how you can figure out the sides of your triangle. Because if you have an equilateral triangle and you drop the altitude, that means that automatically this will have to be 4 divided by 2, which is 2. And using that, you can use the Pythagorean theorem to figure out the third side, which would be 2 square root 3. Right? So now we have the three side lengths of this, right? Of this equilateral triangle. And using this, we can figure out what is the area of one of the triangle. Remember, your area of a triangle is equal to your formula, which is 1 by 2 base times height. Right? So your base is 4. Remember, because we split it into 2 pieces. However, your total triangle still has side lengths of 4. Right? So 4 divided by 2 times your height, which is 2 square root 3. Right? So this is 4 divided by 2 is 2. So 2 times 2 square root 3 is 4 square root 3. Okay, and remember, that's your that's just the combined area. That's just one triangle's area. We need the combined area of just the shaded regions. So if we see here, there are 2 shaded regions, so we need to multiply that by 2, and we would get 8 square root 3. And remember to be really careful and read the question, because it says the combined area of just the shaded region. If you skim your problem and just see the words combined area, you might decide to multiply by 3. Thankfully, that answer isn't here in this question. However, that is definitely an option that might come in the SAT to try and trick you. Anyways, the other way that you can try and solve this problem is by knowing the area of your equilateral triangle formula. Okay, and that formula is square root 3 over 4 times, I'm just putting a dot to represent multiplication, your side length squared. Okay, so your side length is 4, so 4 times 4 is 16. 16 divided by 4 is 4, so 4 square root 3. So this is just a bit quicker because you don't need to drop the altitude and figure out your special right triangle. You can just know the formula and go along with this. And as always, we have 2 shaded regions, so you can multiply it by 2, and you get 8 square root 3, just like we did using our first method. Now, our last problem says the perimeter of an equilateral triangle is 624 centimeters. The height of this triangle is k square root 3 centimeters, where k is a constant. What is the value of k? We just kind of did this in our previous problem. Remember, if we have an equilateral triangle, if you drop the altitude, right, and say this is 2x, this would be x, and then this would automatically be x square root 3, right, your altitude. So we just need to figure out what is x. So how are you going to figure out x? Well, it's kind of obvious. We need to figure out what is your side length and divide it by 2. So your perimeter is 624. So we divide your perimeter by 3, since remember, each of these are the same side length. We can find out what is the length of one side. So dividing it by 3, we get 208. Right? And that's the length of one of our sides. And this is equal to 2x. So if 2x is equal to 208, that means that x is equal to 104. And that's what we just needed to figure out. What is x, which is in this case k. And that is our answer, 104. And that is how we solve this problem. So when approaching any trigonometry problem or like special right triangle problem in your SAT, all you need to do is basically memorize how to solve you just need to memorize your trigonometry ratios as well as your special right triangle, angles and side lengths. And that's all I have for you guys today, and thank you very much.